I'm Christina Margarita. I'm from the University of the Aegean in Greece. And the topic of my presentation is the investigation of the corrosion-induced damage mechanism of aeronautical aluminum alloys 2024 and 2198 riveted sheets, which was performed in collaboration with the National Technical University of Athens. Actually, to be honest, in this presentation today, only the results for 2024 are included because this is a preliminary work. Okay, aeronautical aluminum alloys of 2000 series with aluminum and copper in the maximum percentages are widely used in aircraft structures and mainly in the lower skin and upper wings. These materials are still widely used because due to the lightweight, the increased corrosion resistance, the increased damage tolerance, low cost, and the major manufacturing processes. Riveting are one of the main joining techniques in aircraft structures, mainly because of the stability, the long life, the high reliability, and the simple production processes and high efficiency. Okay. The main technological problem that is met in several damages problems is the corrosion with a percent of approximately 40% regarding an investigation in Boeing 747. The 2000 series aluminum copper alloys are highly susceptible to localized corrosion, and one of the main reasons where localized corrosion is caused is the surface heterogeneity, such as the joints and rivets. In this work, as I already told you, the results for the aluminum alloy 2024 will be presented. The configuration of our specimens is shown in this slide, where a rivet hole was performed of 4.76 millimeters in diameter. And the specimens were exposed to the exfoliation corrosion solution. So the experimental procedure consisted of the grinding of the specimens, drilling, corrosion exposure by simple immersion for several hours, and mechanical testing and microscopy. The experimental procedure consisted of two different cases. The first case included specimens which were corroded in all surfaces, both inside the rivet hole and in the surfaces outside of the rivet hole, the upper and down surface of the specimen. Case B included specimens which were corroded only inside the rivet hole, and case C included specimens corroded only in the layers outside of the rivet hole. And several hours exposure to the exclusive solution were selected. The exclusive solution was selected because it is a widely used solution for the simulation of corrosion in aeronautics, because it is a very aggressive solution and better simulates the pitting attack. And also in a previous investigation of our team, we noticed that, for example, if we compare the EXCO solution with the 3.5 weight percentage sodium chloride, only 24 hours exposure to EXCO are needed in order to have the same degradation of elongation of fracture with 6 months exposure to the sodium chloride solution. So we are moving to the experimental results. Here, some macro photos of the corroded specimens are presented, which show the evolution of surface deterioration with increasing corrosion exposure time for 2 hours, where some pits on the surface are noticed, and 6 hours, and the extremely high corrosion exposure time, 48 hours, where exfoliation corrosion is evident in the surface. In this slide, the results for case B, where only the inside of the rivet hole was corroded. Again, the evolution of corrosion is presented. And as you can see, in the extremely high exposure time, several cracks are noticed. And here are the results for the macro photos for the case C, where only the area outside of the rivet hole was corroded. Regarding the results of the tensile test, firstly, I'm going to show you the case A results for the corrosion in all surfaces. It was noticed that significant degrees of both stress and strain is evident even after only 2 hours corrosion exposure time. And moving to higher exposure times, it is evident that no significant stress noticed for the high exposure times, but a significant decrease in strain was noticed. Moving to the results for case B, corrosion only inside rivet hole, again, a significant decrease of both stress and strain is noticed after 2 hours corrosion exposure. After 6 hours corrosion, the stress is not so significantly reduced, but the strain decreases continuously with increasing exposure time. But again, in the high exposure times, this difference is not so essential. Regarding the results for case C, where only the layers outside of rivet hole were corroded, no essential decrease in stress is evident for 2 hours corrosion exposure time, where pitting attack is limited, but an essential decrease in strain can be noticed. A noticeable reduction in both stress and strain is seen for 6 hours, while increasing the exposure time to 12 hours, there's no significant decrease, neither in stress and strain, but after 48 hours of corrosion due to extensive exfoliation, both stress and strain are significantly decreased. The analysis of these results, the results of tensile tests, starts with the presentation of the normalized values of the average values of conventional yield stress with regard to exposure time to EXCO solution. And it is evident that specimens corroded at all surfaces represented by the red curve saw the greatest reduction in conventional yield stress for the whole corrosion exposure time. While specimens corroded only inside the hole, represented by the black curve, saw a greater reduction of the conventional yield stress for short exposure times and up to 12 hours. And at long corrosion exposure times, more than 24 hours, the inside hole corroded specimens showed a slightly smaller reduction. Moving to the results of ultimate tensile strength, specimens corroded only outside hole, represented by the black, by the blue curve, presented better corrosion resistance for the short exposure times, while after 24 hours, where already exfoliation had been formed, the samples were corroded only inside the hull, showed better corrosion resistance. And now moving to the most important property, to elongation at fracture. It was noticed that higher corrosion-induced degradation noticed for the corroded specimens where the rivet hull was exposed to corrosion. So it seems that rivet hull, the area inside rivet hull, essentially affects this property due to stress concentration phenomena, while accumulated damage on large surfaces seems not to play so significant result, as we can see from the blue curve. So reaching to our conclusions, surface deteriorations remains limited for short exposure times and up to 2 hours. However, pitting corrosion was gathered around the perimeter of the rivet hull. While for long exposure times, extensive exfoliation was noticed in the large surfaces, both near and far from the rivet hull, and specimens corroded on all surfaces showed a reduced corrosion resistance regarding the mechanical strength properties, while specimens where the inside of the hull was also exposed to the expo solution showed higher corrosion degradation for all exposure times. And the interior surface of the hull was found to play the most decisive role in this corrosion degradation. This work was funded by the Hellenic Foundation for Research and Innovation. Thank you for the attention.